As I have already given you an overview of multivariate data analysis, let's deeply understand. It is defined as a process involving multiple dependent variables resulting in one outcome. This explains that the majority of problems in the real world are multivariate. For example, we cannot predict the weather of any year based on the season. There are multiple factors like pollution, humidity, precipitation, etc. Here, we will introduce you to multivariate data analysis, its history, its application, its objectives, and techniques. So before we go into application, let's get a little bit of history of multivariate. So in 1928, Wishart presented his paper, The Precise Distribution of the Sample Covariance Matrix of the Multivariate Normal Population, which is the initiation of MVA. In 1930s, S.N. Roy and B.L. and others did a lot of fundamentals theoretical work on multivariate analysis. At that time, it was widely used in the fields of psychology, education, and biology. Let's understand the application of multivariate data analysis. So in the middle of 1950s, with the appearance and expansion of computers, multivariate analysis began to play a big role in geological, meteorological, medical, social, and science. From then on, new theories and new methods were proposed and tested constantly by practice, and at the same time, more application fields were exploited. With the aid of modern computers, we can apply methodology of multivariate analysis to do rather complex statistical analysis. As time advanced, MVA was extended to the fields of meteorology, geology, science, and medicines in the mid-1950s. Today, it more focuses on two types of statistics: descriptive and inferential statistics. We frequently find the best linear combination of variables that are mathematically in the descriptive region. But an inference is an informed estimate that is meant to save analyst time from diving too deeply into the data.